Dear student of any Model Science School, I'm going to be teaching you physics for KS3 Year 7 Isaac Newton. I'm by name Teacher Abdulatif Suleiman. Today we are going to be dealing with a very important topic, a topic you have been waiting for. Before then, I want you to study these diagrams very well. You can equally see here, what do you observe here? What do you think is here? And what do you think is happening here? I'll give you some seconds to do that. Okay. Now I have this question. What do you observe? And what do you think the topic will be? Considering you have this. Okay, you have this, you have that. Okay. So, the nice one. Now the topic is energy. Now, yes, energy. Going back to this first slide, we're going to discover you have this energy, which is solar energy, which you have been taught, energy from the sun. Good. Here is a solar panel that traps energy from this very same sun to itself. Now, this very solar panel, the energy here is being converted to electricity, which you enjoy in your various houses. Can now see what we're talking about here, energy. Now, energy, let's see the definition for energy. Yes, energy is the ability to do work. Yes, energy can exist in different forms, which can be mechanical energy, chemical energy, electrical energy, light energy, sound energy, solar energy, nuclear energy, and so on and so forth. Now, before now, you are aware of one form of energy or the other. You'll be saying it's solar. Okay, this is what we call solar energy. Now, this energy is measured in joules. As you can see here, you guys have been doing this. You have your cell. In your cell, you connect your wire, connecting wire to the first leg of your bulb. You connect the second wire to the second terminal of your bulb. By the time you connect this, you discover that you have the light. So what do you think is happening here? Energy exists between this very same cell. Yes, there's an energy in this very same cell. At the end of the day, you end up converting this energy to the one here, which is called light energy. So that's part of what we're going to be discussing as far as this very same topic is concerned. Let's go to the next slide, which we're going to talk about mechanical energy. Mechanical energy is just a simple aspect of this very same forms of energy we are going to talk about today, because it's very, very important, and you use mechanical energy like almost all the time. Now, this mechanical energy is subdivided into two. Mechanical energy is the energy a body possesses by virtue of either its motion or its position. Now, look at it here. You have the first one with potential energy, which is the energy a body possesses by virtue of its position. The body shows an object as in a particular position possesses potential energy. Are we together? Now, to calculate the potential energy of a body, you can use the formula below, which is mgh. Which is what? mgh. Now, for the m is the mass of the object, the g as relation to gravity of the object, and the height, which is the h, the height of the object. Now, I believe we're together. Good. Because what we're trying to talk about here, you have this potential energy. This ball is at this very same tip. This ball is not moving to anywhere. The ball is at rest. At this point, this ball possesses potential energy. Are we together? Okay. You can see this man here riding bicycle. At this point, where the man is not ascending nor descending, at this point, this very same boy possesses potential energy. Are we together? So, let's talk about the next one, which is the kinetic energy. Kinetic energy is the energy a body possesses by virtue of its motion. Now, when you discover a body in motion, when you discover a body moving, not stopping, we're going to say that very body possesses kinetic energy. It is given by the formula 1/2 mv squared. That way you can just say half mv squared. Yeah, 1/2 mv squared. The m is the mass of the object and the v is the velocity at which the object is moving. We are dealing with motion now. The velocity at which the object is moving. Or you have square here, which is going to be the square of your velocity. So anything you have here as a velocity, you take the square. Good. Thank you. You can see what is happening here. This man has his arrow. Before he shoots this arrow, he has potential energy. Immediately you release this arrow, the arrow is in motion. So at this point, it's no more potential energy, but here is what? Kinetic energy. Likewise, this man here is trying to roll this ball. But at this point, the ball is still at a resting position, so that's potential energy. But immediately release and just push this very ball to ascend to the ground level. Like what you are seeing here, at this point, the ball is in motion, so we're going to say the ball possesses kinetic energy. Are we together? Good. So let's go to the next slide, which we're going to be talking about the transfer of this energy when work is done. How is this energy being transferred from one form to the other? At the end of the day, what relationship do they have with work done? And this is what we have here. Most mechanical and human activity represent interchange of energies from kinetic energy, potential energy, and work done. So for you to have work that is being done, you must have interchangeable energies within them, either potential energy or kinetic energy or both of them. Now, transfer of energy can be observed when a boy pushes a car where the potential energy, the energy stored on that very same boy, with its kinetic energy will bring about movement of the car from its original position. So at this point, when the car starts moving, the car possesses potential. The work is done by the car start moving. But by the time it starts moving, you are going to say that very car possesses kinetic energy. So definitely, for that very car to move, work is being done. I believe you are getting it. Thank you very much. So let's go to the next slide. We're going to talk about the assignment you have. And the assignment is this. You have to briefly explain the transformation of energy that exists in the following. The transformation of energy, the energy that is being transferred from one form to the other. So as you have your torchlight, let me give you an instance. You have a torchlight, energy is being transformed from a torchlight, from your battery, for you to have the light in your room. Like the first light we saw the other time, and you have your cell, you attach your bulb to it. You have your cell, which is in form of a chemical energy. You have your light, which is giving you, you have your bulb, which is end up giving you light. So you have conversion of energy, transformation of energy from chemical energy to light energy. Are we together? So you have the same thing here. You're going to explain the transformation of energy that exists in torchlight. You are going to explain likewise the one that exists in electric bell. You are going to explain the one that exists in rotation fan. You are going to explain the one that exists in electric cooker. I'm going to explain the one that exists in electric iron. And this brings us to the end of the class for today. Thanks. God bless you.